Welcome to Rges Algebra 1, Lesson 19A. We're continuing our discussion about solving simultaneous equations, which means that we have two or more equations and we want to know what point will make both equations true, or all the equations true. Okay, and so the first method we learned would be graphing. It would be the most inaccurate method, but in some ways the most straightforward method. We're simply looking for the point of intersection. The second method was what we did last time, and that's called substitution. We solve one of the equations in terms of another variable or variables, and then we plug that in. Okay. So that if we only are having two equations, which is what we're dealing with now, let's say we would solve one equation for either x or y, and we would plug that expression into the other equation for whatever variable we solved for. Then we only have one variable now. Either all x's or all y's will solve for an answer, an actual constant, and then we'll plug that into the first equation we solved for to get the y, other value, y or x. There's so many choices, it's hard to summarize that. All right, now this time what we're going to do is we're going to add or subtract two equations together such that one variable drops out, quote unquote. That means when you add it, it will end up being 0. So we've talked a little about this already in class, so I want to just go ahead and illustrate a couple examples for you right now. Let's say we have 5x plus 3y equals 25. And also, that's 25. I better make sure you understand that. And then 7x minus 3y equals -1. Well, I notice that both the numerical part and the variable are the same in the y's. So if I added these two equations together, my x's would be 12x, positive 3y, and negative 3y would be nothing, and 25 minus 1 would be 24. Signs become very, very important as you're doing this method. They call it by combination. That's a pretty good name for it. It's often called by elimination because we're eliminating one variable. The combination emphasizes the idea that this could be a positive or a negative here. And when it's a negative, when I need to subtract, in other words, if I'd had plus 3y in the first equation and plus 3y in the second equation, I would need to subtract the one from the other, and signs are trickier because you could, if I put a subtraction out here in front, I might lose it if I'm not careful and ignore it. So at any rate, I would solve getting x equals 2 here, and now I would take that value and plug into either equation 1 or equation 2. It's absolutely irrelevant to solve now for y. So I'll do equation 1, 5 times 2 plus 3y equals 25. 5 times 2 is 10. Copy everything else, do your order, be methodical, copy everything down, don't do little chicken scratch to the side. I want to see everything step by step. Now what we're going to do here is subtract 10 from the other side. 25 minus 10 is 15. We're going to do the opposite of multiplying by y, which would be dividing. We're multiplying by 3 on the left side, so we'll divide by 3 on the right side. 15 divided by 3 is 5. Remember, my goal is an ordered pair, 2, 5. How would I check it? I would go back into both equations. Equation 1, let's see, that would be 5 times 2 is 10, plus 3 times 5 plus 15, 10 plus 15, that's 25. go into equation 2. So you can do this mentally or write it out. It doesn't matter to me, but make sure you do it accurately. 7 times 2 is 14. 14 minus 3 times 5 are 15. And of course, I'm getting these substitutions right from my point. 14 minus 15 is minus 1. So you have to check it. For this, I must check it in both equations. Now for the second example that they give you in the book, 5 and 2 do not match for my x numerical constants or numerical coefficients, and 3 and negative 4 do not match. But if I multiplied the first equation by 2 and the second equation by 5, my x's would drop out. They would both be 10. If I multiplied my first equation by 4 and my second equation by 3, my y's would drop out. They would both be 12. So you can do either one. I'm going to do the first one. I'm going to make my x's dropped out by looking for the least common factor. And if I multiply this one by 2, I'd get 10x. If I multiplied this one by 5, I would get 10x. So let's do that. Now recall, you have to multiply every term on the left and right side. I would get 10x plus 6y multiplying by 2 equals 18. Multiplying by 5 in the second equation, I would get 10x minus, multiplied by 5, you get 20y. Notice all the little places you can make mistakes here. And 5 times 40, don't forget, even the right side of the equation, is 200. Now, this is a good one to choose because it's the x's that I'm going to eliminate, but the bottom one I better subtract. Now, I could subtract right away by changing every sign. I might even do that with another color just to bolden that. I could either put it in front with a parenthesis and have to pay attention each time, or I'll change each sign right away. Negative, positive, negative. And that'll help me remember. 10x minus 10x drops out. That's my goal. Positive 6 minus 20 is negative 14. I'm sorry, I made a mistake because I'm always used to paying attention to that negative each time, but I already paid attention to it when I wrote in red. So now we are adding 20 plus 6 is 26. Y, there we go. And negative 200 plus 18 would be negative 182. Now, if you go ahead and divide, you're going to get y equals negative 7. Now, you go back to either one of the original equations, plug in, and get x. I think I'll go ahead and take the first one, 5x plus 3 times negative 7 equals 9. 5x, notice how methodical I'm being, write down your steps. 3 times negative 7 is negative 21. The opposite of adding is, the opposite of subtracting is adding. And so we're going to add 21 to the other side. And the opposite of multiplying is dividing. So we're going to divide the other side. 30 divided by 5 is 6. So my answer will be an ordered pair, 6, negative 7. To check, I have to go into the original two equations. 6, 5 times 6 is 30, minus 21, that equals 9. And 12 plus 28, 38, 40. Okay. So that's how you do these problems. Now, I will say they do explain it with a little different technique. Rather than figuring out if you're going to add or subtract, what he says is, I notice the first one's positive here, and I'm going to multiply to get 10, then I want to multiply to get negative 10. So this will be 10, so I'll multiply each one by the negative 5. And then we always add. That's probably a good way to look at it. And the reason why I say that is the signs is where most of the students make their mistakes. So if you already think about multiplying by a positive or negative, whichever you need, you'll probably be less inclined to make that mistake. Now, if you will grab your textbook and turn to page 317, I want to talk you through the oral practice problems quickly. So 317 in your textbook, I'll put it on pause for a second and wait for you, and you put it on pause and grab it. Okay, so they're asking you in these first examples, give the equation that results after you add to eliminate a variable. So in the example, we will be eliminating the y, so the first step of our equation will be, after we've eliminated, will be 8x. We're adding the x's, the y's drop out. We're adding the constants on the right side, so it'd be 8x equals 11. A, our y's will drop out. It will be 6x equals 12. Make sure you're following along. Look at B for a second. Think about it. Put it on pause if you need to. Y's will drop out. 9x equals 12. So just look at these problems with me, and I think you'll get them pretty quickly. C, x's will drop out. 13x equals 10 minus 3, 7. D, x's will drop out. 9y equals 8 minus 1, or 7. E, my y's will drop out. I'll get x equals 2. So I'll be done. And then go back and solve for y. And then F, my x's will drop out. I'm going to get 5y equals 4. So hopefully that's easy enough for you. If you look at the second set, now they're asking, what should my multipliers be? Well, you could just simply always, you don't always have to. What I would do is, maybe to be just real easy and systematic, well, you'd probably pick the smaller numbers. Okay, in other words, what I have here is 5x plus 3y equals 9, 2x minus 8y equals 4. My 5 and my 2 are the smaller two numbers. I can't just do a multiplication of one of the equations to make it drop out, so I'm going to multiply the top equation by the 2, the coefficient on the second equation, and the bottom equation by negative 5, the coefficient of the top. Let me just write that out for you. Okay, so I'm going to take the x's, because their numerical coefficients are a little smaller. Smaller numbers are always better. I'm going to multiply the top one by the 2, and the bottom one by the 5 with the opposite sign. Okay, just like that. Look then at G. Think with me. You're going to have to multiply both. So I'll make the x's drop out because they're smaller. I will multiply the top equation by 3 and the bottom equation by negative 2. It doesn't matter. I think I'll do the 4 and the 5. The numbers are just about the same, I guess. I will multiply there's a little trick here. Multiply the top by 5 and the bottom by 4. Not negative 4 because it's already an opposite sign. See what's going on there? For I is interesting because I could either get the x's to drop out by only multiplying the top equation by negative 4, or I could get the y's to drop out by only multiplying the bottom equation by negative 2. Make sure you're following this. It will make the problem sets go a lot faster if you can see this quickly. in your head. It says tell the number by which each equation should be multiplied to eliminate y. Okay, to eliminate y for j, I'll multiply, oh, actually above they told you to eliminate x. I failed to notice that rather than giving you choices. Okay, to eliminate y, j, I'll multiply the top equation by 4 and the bottom equation by -5. K, the top equation by 8. They're already opposite signs, so the bottom equation by +3. Okay. So that would be -24 on the top and +24 on the bottom. That's what I need, opposite signs. And for y, again, the bottom equation only multiplied by -2. All right, so hopefully that's clear to you. I want you to do all the way through 43 odd. I want you to get lots of practice with this and be very familiar with it. Now, those last 4 problems are a review from things we've done earlier, so go back if you need to review that. Recall that it says, let's see, find the slope, right, by rise over run using both points, and then I would just say always use the first point. Oh, the Y-intercept can be found. Okay, I teach that a little differently. I would say for numbers 41 through 43, I used to teach it that way, 41 and 43, you want to first find the slope by using both points, the difference in the y over the difference in the x. Use both points to do that. Then you take your first point and your slope. Okay, first point, so you'll have an x and a y. And you'll have your slope, your m. Then you're going to use this equation. Y minus y1 equals mx minus x1. This is the easiest way, I think. You'll plug in there, plug in there, plug in there, and that'll be your answer. Okay, very straightforward. Okay, have a good day, and we'll see you soon in class.